Hi, today my topics here it is effective rate of interest. So effective rate corresponding to a stated rate of interest are here stated rate of interest means nominal rate of interest or annual rate of interest. It is R compounded m times per year. Compounded m times per year. If it is say semi annually, so m value will be 2. If it is quarterly, value of m will be 4. If it is monthly, value of m will be 12. And most of the cases, interest it is compounded more than once per year. So here for finding effective rate of interest, we will use this formula 1 plus r by m to the power m. It is here r by m. This r it is annual interest rate already I mentioned here, and this I it is rate per period. Suppose if quarterly m value will be 4, then this r will be divided by 4. And here n equal to mt, this m, it is the number of compounding periods. In a year, if it is quarterly, so m value will be 4. If it is for 2 years, so it will be 8. How to get that? Per year 4 multiplied by for 2 years. So we have to use then this n equal to mt. This is 4. For 2 years it will be 2. So it is mt. So this formula we will use for finding effective rate of interest. So let's move ahead in the next slide to see how to find this. I have taken a very simple formula, simple problem. Here, this is the formula already we have seen in the previous slide. So, if I deposit $1 at 8% compounded semi-annually, so 8% means it is the value of R. Semi-annually, it means periods, number of compounding periods per year, it is 2. Most important point, m equal to 2. So easily we can find I equal to R by m, 0.08 by 2, 0.04. So here directly we can write 0.04 also, or like this, same thing. So same formula, 1 plus R by m, we put this value, and square means it is semi-annually, so value of m will be 2, and it is for 1 year. That's why it is here 2. So if we calculate by calculator, we get this 1.0816, and look at here, it is written at the end of 1 year, the compound amount, it is this. Now, so this is the formula for finding compound amount. So once we get this 1.0816, actually how much I deposited? $1. So I can say $1 increased to $1.0816. So what is the effective rate of interest? This value minus of 1, as per this equation, it will be 0.0816. So actual increase is 8.16%. So very easily we can say this is the effective rate, and it is 8.16%. And this 8%, what was in the questions, annual interest rate, this is nominal or stated rate, which is 8%. So this is somewhat higher than the stated rate. This is very important points. Here I have taken one example to understand this effective rate of interest. So what question says, this Sanim, he got a credit card and its limit is $1,000 and annual interest charge on his balance will be 20%, and make sure here to understand this point, payable monthly. So number of periods in a year will be 12. It means M value will be 12. Payable monthly. He immediately used his card to its limit. It means he already spent $1,000. So after getting first statement, he found that his balance is 1,000. Of course it would be. But no interest has yet been charged. Each subsequent statement includes interest on the unpaid part of his previous monthly statement, but he ignores the statement for a year without paying any money towards the balance owed. It means he never paid his balance. So in this situation, what amount does Sanim owe according to his 13th statements? It means after 1 year. What will be effective rate of interest? So already we know how to find effective rate of interest. As well, we know how to find amount Sanim owe. So this is the formula, P into 1 plus I, and this I we know, interest rate per period, this one. So at the end of the year, the compound amount is, how much it will be? Principal is 1,000, 1 plus this I means we can use R by M. So 0.2, it is 20%, 0.2 divided by 12, and this N value will be same as M equal to 12 because here it is for 1 year. 1 year and per year 12 periods. So here it will be 12. So by calculator we get this value, $1219.39. This is one thing. Now using this value we can find effective rate also, but I will show it later. First I am using this equation for getting the effective rate. So the effective rate will be this part, already we got it here. This is minus of 1. This minus of 1. So what we are doing here, R by M, 0.2 by 12, 1 to the power 12 minus of 1. So we get 0.2194, this value. So the effective rate is 21.94%. Right away we got this. Now this one also, using this we can find same interest rate, this one, effective interest rate. How? Effective rate is this amount we got here minus of 1,000 we had principal divided by the principal, we get this 0.2194. So this is 21.94% effective rate. This is one way to get, or we can use this formula for effective rate, 1 plus this to the power 12 minus 1 equal to 0.2194. So nominal rate was 20%, but actual interest charge will be 21.94%. That is why it is effective rate. Now we will discuss here about present value. So already we have seen this formula. Compound amount formula is this. Already we know I equal to R by M, N equal to MT. So this equation we can rearrange. I mean P we can bring it on the left because we are talking about present value. So present value actually this P. So Z will be here divided by this. It can be like this or it can be like this. If we are asked to find the present value, right away we can use directly this one or this one. Let's see an example in the next slide to see how to find that. So here question is find the present value of 20,000 in 10 years. After 10 years 20,000. If money can be deposited at 6% compounded semi-annually. Very clearly semi-annually. Right here we know m equal to 2. M equal to 2. Number of compounding periods per year it is 2. And as it is for 10 years, if we multiply 10 years for per year, compounding period is 2. So total periods will be 20 for 20 years. So present value for compound interest, it will be Z by this, because already we have seen this formula. Then 20.06 by 2 by calculator we find this $11,073.52. So 52 cents. So $11,073.52. This is the answer for the present value. Suppose 5,000 is deposited now at 4% compounded quarterly until it reaches at least 10,000. How much time is required to reach up to 10,000 from the present value of 5,000? So this Z value is 10,000, P is 5,000. We have to find N because how much time is required? We need to find M. It means how much, I mean how many periods we need. It is not years, it is periods. So 4, this is 0.01. So we can easily write this 1 plus 0.01 to the power N equal to, from here this we put at the left side and P we are bringing under this, so it will be Z by P equal to, taking log on both sides, then we'll bring this power in the back, N equal to log 2 divided by log 1.01, dividing these two and using calculator we find it is 69.66. This is number of compounding periods. This is number of compounding periods. These compounding periods, if we divide it by per year compounding period 4, then it will give us how many years? So it will take 17.5 years to reach this 10,000. That's all for today. Thanks for watching.